Welcome back. Let's talk about slope. Okay, if you'll recall, the slope of a line, the slope m of a non-vertical line is the ratio of vertical change, the rise, to the horizontal change, the run. So slope is rise over run, and you've got a little diagram there showing you that the rise is y2 minus y1 and the run is x2 minus x1. So your slope formula is y2 minus y1 over x2 minus x1. This is something you're expected to know. You're not going to be given the formula for slope. You're expected to know it, and you're going to be expected to know it from here on out. Okay? Everybody assumes that people who've had a college prep background in high school knows what slope is and how to calculate it. All right, so let's just start off with an example that actually shows why people care about slope in real life. A skateboard ramp has a rise of 15 inches and a run of 54 inches. What is the slope? You just do rise over run. Okay, and so the rise is 15. The run is 54, so 15 over 54, and we reduce that down. They can both be reduced by 3, so we get 5 over 18. Okay, so that's when you're actually given the rise and the run. Easy to do. Just do the ratio, reduce it. Example 2, we're actually going to calculate the slope. What is the slope of the line passing through the points -1, 3, and 2, -1? So we're going to do y2 minus y1 over x2 minus x1. So we're going to let x1, y1 be -1, 3. So -1 is x1, 3 is y1. 2 is x2, -1 is y2. So we're going to do y2 minus y1 over x2 minus x1. So we're going to have -1 minus 3 over 2 minus -1. So -1 minus 3 is -4. They have a typo on the screen, okay? -1 minus 3 is -4. So make sure you write down -4 over 2 minus -1. That's 2 plus 1, which is 3. Now, they forgot to put down the negative, but they realized it's -4/3 because they do pick A as the correct answer. Sorry, I wish I could edit this, but I can't, and the slides are just too good for me to throw it out for one little baby mistake. So just make sure you know m is equal to -4/3. Okay, so moving on to example 3. For example 3, we're going to use the classifications of lines by slope. The slope of a line indicates whether the line rises from left to right, falls from left to right, is horizontal, or is vertical. When you have a positive slope, it goes up from left to right. So it rises from left to right if you have a positive slope. So positive slopes rise. Negative slopes fall from left to right. So negative slope falls. A zero slope is horizontal, and a vertical slope is undefined. Okay. Technically, it's not a vertical slope. A vertical line has an undefined slope. So if you end up with an undefined slope, you've got a vertical line. Now, for a zero slope, you're going to have 0 on top. For a vertical slope, you have 0 on the bottom. Okay. Note a vertical line has undefined slope because for any 2 points, the slope's formula denominator becomes 0 and division by 0 is undefined. Okay, so example 3. Without graphing, tell whether the line through the given points rises, falls, is horizontal, or is vertical. So what they want you to do is be able to classify based on what we just talked about. Positive rises, negative falls, 0 horizontal, undefined vertical. So we have -5, 1, 3, 1. That's our first point. And then we've got part B, C, and D. Here's all our points. So we're going to use the slope formula for each of these and then interpret. Okay, so for our first one, we're going to have 1 minus 1 over 3 minus -5 using y2 minus y1 over x2 minus x1. Y'all have done this for years, so I'm not going to spend a whole lot of time going through the little bits and pieces of it. 1 minus 1 is 0 over 8 is 0. 0 on top is 0. Think of it like a little bubble. If you're blowing bubbles, if there's a bubble on top of if a bubble lands on top of something, it's going to stay there maybe for a few minutes. So bubble on top can survive. That's 0. And so that's horizontal. Because m is 0, the line is horizontal. Let's look at B. For B, you've got negative 4 minus 0 over 2 minus negative 6. So that gives you negative 4 over 8, which reduces to negative 1/2. This is a negative line, so the line falls. The negative slope means the line falls. Because m is less than 0, or because m is negative, the line falls. Okay, for C, we've got 8 minus 3 over 5 minus negative 1. So that's going to give you 5 over 6, which is positive, so the line rises. Because m is greater than 0, that's another way of saying m is positive, the line rises. And finally, for part D, we've got negative 1 minus 6 over 4 minus 4, so that's negative 7 over 0. 0 on the bottom can't survive. So just like if you blew a bubble and then you put, I don't know, you drop something on top of it, if you drop something on top of the bubble, it's going to pop. So when you've got a bubble on the bottom, the whole thing pops. It's undefined. Because m is undefined, the line is vertical. Okay, undefined slope is for a vertical line. Okay, we've got one more example, and it's about parallel and perpendicular lines. And I know you've covered this probably in Algebra 1, and then I know you cover it in geometry, but it's a big concept and we need to talk about it. So we're going to consider two different non-vertical lines, line 1 and line 2, L1 and L2, with slopes M1 and M2. Okay, so L1 has slope M1, L2 has slope M2. The lines are parallel if and only if they have the same slope. So M1 equals M2. Parallel lines have equal slopes. Perpendicular lines have slopes that multiply to be negative 1. The lines are perpendicular if and only if their slopes are negative reciprocals of each other. That means they have opposite signs and are reciprocals. So there's two ways to think about this. M1 equals negative 1 over M2, or when you multiply M1 times M2, you get negative 1. Okay. All right, so for example 1, we're going to tell whether the lines are parallel, which means their slopes are equal, perpendicular, the slopes multiply to be negative 1, or neither. Anything else occurs. Okay. So if the slopes are equal to each other, you've got parallel lines. If they multiply to negative 1, you've got perpendicular lines. If anything else is true, then the lines are neither parallel nor perpendicular. Okay, so for part A, we've got line 1 going through negative 2, 2, and 0, negative 1. We also have line 2 going through negative 4, negative 1, and 2, 3. So the process here is you find the slope for each line and then you compare them. You look to see if they're equal, which means they're parallel. You look to see if they multiply to be negative 1, which means they're perpendicular, or if they have any other relationship to each other, it's neither. And then for B, we've got another pair of lines. Okay, so we're going to find the slope of the two lines. For the first line, for M1, we have negative 1 minus 2 over 0 minus negative 2. So that gives us negative 3/2. For line 2, we've got a slope of 3 minus negative 1 over 2 minus negative 4. So that gives us 4/6, which reduces to 2/3. Because M1 times M2 equals negative 3/2 times 2/3 equals negative 1, M1 and M2 are negative reciprocals of each other, so the lines are perpendicular. If you just want to show that negative 3/2 times 2/3 equals negative 1 and then write perpendicular, that's great. Okay, for part B, the slope of line 1 is going to be negative 3 minus 2 over 4 minus 1, and so that gives you negative 5/3. For line 2, we've got negative 2 minus 3 over negative 1 minus negative 4, so that gives you negative 5/3. because M1 equals M2 and the lines are different, okay, they're two different lines but they have the same slope, you can conclude that the lines are parallel. So if you just want to show that negative 5/3 equals negative 5/3 and then write parallel underneath it, that's great. Okay, phew, I know these two video lessons have been a little longer than most. I appreciate your attention so much. You've just got two problems to try on your own because the notes took a little longer, and go ahead and try those, and then we'll go over them at the beginning of class and get started on your rounds.